So actually, one of the things that people always miss about me is that I'm not a researcher at Microsoft. I'm actually work in the product group. And I've never been at Microsoft Research. If I would get $1 for everybody that thinks that I'm at Microsoft Research, I could retire. So I run a very small team inside the server and tools division. And we're really, really small team. So one of the things that we do is we don't have a lot of budget. So we go around at Microsoft, there's a lot of office moves. So people sometimes, they work there 2 years and they have like 6 different offices. And every time when there's an office move, people put their old equipment for PC recycle. They put it next to the door. So what we do is we go around and we take, computers that we think still look fine, and we squatted a room where we put up our lab. So this is like just an office, an empty office, where we put all kind of used equipment that was really PC recycle. And as I was trying my demo today, the demo gods were not so nice. They discovered, the big, corporate organization has discovered that we were squatting this office, and it's evacuated right now with my lab in there. So hopefully my guys over in Redmond will be able to kind of, start a server somewhere else, such that I can do the demo. But this is how, like a little intrapreneur-like group operates within, the big corporation. All right. Why are you here at this conference? You're probably here at this conference because you want to learn something new. I hope so. Okay? And what is learning something new? Well, that's forgetting something old or challenging your assumptions about something that you thought you knew. And I think that's what keeps your mind fresh. You always have to look at what you're doing and trying to falsify it. To say, is this really true? Is this really what I want to do? Is this really kind of, the truth? Can I poke holes in it? This is what you do when you test your software, right? So you should do this with yourself too, with your methodologies, with everything. Now, what I want to be falsifying today is the relational database. And I want to check if there's anything, that we can replace it with, or why are we using the relational database? Fortunately, one of the other speakers has already done all my homework, so that I don't have to say this anymore. I can just, show it to you. And yes, so this is what we're going to look at today, and I'm going to kind of, falsify this with a slightly different reason, but what you see from this is that there's a lot of attacks on the status quo. And that always means, when the status quo, when you start to see holes and people are starting to attack it, that means that there might be a scientific revolution coming up. And I do believe that we are, at this kind of, very interesting point in time where a lot of different data models and databases are showing up. And, who knows that Nathan's vision here will be true. So maybe you have witnessed here, a true scientific revolution. Who knows? What I'm going to do, one of the things that I like to do is to think in terms of dualities, things that are each other's opposites. And if you look at our world, and you probably have experience with that, I think there's two kind of people. There's the developers, the guys that actually, and girls that write code, and then there's the modelers. So who here uses a database at work? Who here absolutely loves to use a database? Oh, there are a few strange people there. Good. I'm happy for you. I'm so happy for you. But the rest of, I think, this is the kind of, the 1%. There's the 1%, and the 99% does not like to use a database. And why is that? Let's see. And maybe if you have another reason that I don't mention, just shout it out, and then, we can add it to the list. If you look at modelers, modelers think in terms of nouns. Okay, so they think in terms of customers, orders, line items, in terms of things. And then they write, they declare their tables, and that's it. Okay? Once your data model is done, you can go home and go fishing. Right? For them, the world stops here. You define your data model, you put it in the database, the DBA from then on guards it with like, a big sword. If you try to touch the data model, your head will be chopped off. Now, if you look at this data model, it kind of looks really ugly, I would say. First of all, there's absolutely no abstraction. Okay, it is like, you're defining a class with all public fields and no methods and no data hiding. So if you would hand in a type declaration like that in Programming 101, you would get an F, right? Because we all know you should kind of hide fields with methods, because then you can change the internal representation. Well, the database folks like that because this gives the DBAs full employment. Because if you want to change the schema of the database, suddenly they are very important, and we do have to do schema migration and whatever. But I think they just introduced their own problem. Then the next thing is, if you look at the structure of the database with foreign and primary keys, the arrows go the wrong way. Okay, if you think about an object, a customer has a list of orders. And the list of orders is composed of a list of line items. Not in the relational database. There, the arrows go the other way around. My customers and my orders, the orders belong to a customer. So if I want to grab a single customer out of the database, I have to scan all the line items and all the orders to make sure that I match up the keys, and then I can get my single customer out of there. And then you can say, but Eric, have you never heard of an index? Well, if you think about it, what an index does, an index allows you to kind of, say on orders, it allows you to get all the line items that belong to that order in a single lookup. Well, you have recreated the list that you had in the objects in the first place. So, if you have indexes, why don't you start with objects in the first place? But the other thing, the really bad thing about this, is that you have to show the whole structure of the objects, otherwise you cannot do joins. So you have to expose the structure of your tables, because otherwise you cannot navigate the relationships. You always have to have the two types, and then, walk through them in order to navigate. Whereas in objects, I can completely hide that. Okay? So databases have absolutely no abstraction. You define the nouns, and that's it. Anybody agrees here? Or disagrees? If you disagree, just shout, start, throwing tomatoes, bananas, whatever you want. Okay, but databases are declarative. Now, what does declarative mean? Declarative often means good. Okay, so you can end any technical discussion by saying, oh, but this is declarative. And then everybody goes, oh, yeah, it's declarative. I think declarative is BS. Declarative really is a relative term. If you're an assembly programmer, C or even maybe C++ even looks declarative. Okay? But if you're a C# programmer or a Java programmer or maybe a Haskell programmer, C++ looks imperative. Okay? So it's all about relative where you are. So things are not declarative by themselves. They are declarative relative to something else. So what is SQL declarative to relatively? I don't know. When I look at this code, I don't think it's very declarative. It exposes all the details of my data model. It shows me that, if I want to navigate, between customers and orders and line items, I have to know about keys and do joins. And then, I can write this maybe with a join. But then I have to say, is it an inner, outer join? Maybe I have to give hints if it's a hash join or an acqui join. It's not declarative at all. It's incredibly imperative. And then, if you look at this thing does 3 nested loops. If I just read this, it's 3 nested loops. But the database has some magic. There's magic ponies in the database. Really. Because you write nested loops, and it will magically turn it into something that uses indexes. What were indexes again? Those just correspond to objects with, collection-based values. So the magic pony turns something back into objects. Why didn't we start with objects in the first place? This is kind of weird. It's like running the marathon with a ball and chain on your leg, and then you end up at the finish, and you say, look how great I am. Well, if you would have cut off that ball and chain, you would have been way faster, and it would have been way easier. So, declarative, not so much. The other thing, I think, if you look as a programming language, SQL is kind of weird. And I noticed in GoTo, in Aarhus, that Perl now has the same convention, this notation for aggregates. Who here thinks that's natural? Not even the database fanboys over there? Not even, look at this. This is how remarkable. Not even the database fanboys in the back of the room, okay, think that this is intuitive. Look at this. I'm doing a sum, but it's not over a collection. I give you, so implicitly there's kind of, some looping over there with this kind of aggregate notation. This always, confuses me. And I'm happy even the database fanboys in the back are confused. Love it. Thank you guys. You could not have been a better supporter for my argument. Okay, now let's look at this. Recursion. Recursion. That's hard. That's advanced. That is for graduate students. They can do recursion. Now, if you do a recursion in SQL, you can do it. But here's a recursive query that computes the factorial. My goodness, does this look declarative to you? It doesn't look to me. It looks like token soup or token salad or whatever you want to call it. But this is not declarative. And if you look at it, it's extremely imperative because even the syntax shows how the recursion works. It works by computing a fixed point. You start with a small set and then you kind of, add elements to it until the set kind of doesn't grow anymore. So the implementation of recursion is directly exposed in the query. Imagine that in Java you would have to, if you define a recursive function, you would have to say, recursive function, allocate 5 elements on the stack, and nobody wanted to do that. Well, if you're using ML, you have to say whether a data type is recursive. So it's kind of a little bit like this. So there's also functional languages that are not as declarative as you might think. Anybody here uses like ML or Camel where you have to say that something is letrec instead of let? Same as SQL. Bad thing. All right. Now, the database people do a few things right. Okay, I shouldn't complain too much. And one of the interesting things that they do is they say, well, everything is a database. So even the database is exposed as a database. So they have meta programming in SQL. So you can view, the system tables and so on as a database. Now, again, I think the idea of kind of making everything uniform is great. I think that's one of the signs of a fantastic language. That's, for example, why I like Haskell, because everything is a function and functions can be used everywhere. So you only have to understand one thing, or JavaScript, where everything, all objects are just hash tables. So that makes it conceptually easy. But I'm not so sure that, specifying your system or giving a view of your system as a database is the most easy way to do that. Because as we've seen, the relational model is kind of a little bit weird with the foreign and primary keys. But at least, they did a little bit right. All right. Now here's another thing. That's one of my hobby horses. And that's first order versus higher order. Okay. What I like in a programming language or in any system is that you make no exceptions. Let's take, for example, an object-oriented language. Imagine that you would have an object-oriented language where every object could only have scalars as fields. Okay, you cannot have any other objects. You cannot have recursive nested objects. That would suck, right? I mean, I don't know how I would write code. If I could only define classes that have scalar fields and I could have no methods, no protection, well, that's what SQL gives you. Okay? So SQL is inherently first order. And this is important because that's how they can lay out the tables and know exactly what the schema is and so on. But it's inherently first order, which means that tables cannot be values inside tables. You cannot have a query returning, another table with nested tables. I cannot have a query that takes a query as a parameter. It's very much first order. And what I like is higher orderness. Like, I can take an object and I can pass that as an argument to a method and I can return it as a result from a method and there's no limitations on anything. I can compose things at an arbitrary depth. Now, the advantage of first order is that you can draw pictures. Okay? If you have higher orderness, if you have things where, say that I have here my query, that kind of little picture on the bottom. If a query was an object by itself that could flow through the system, it becomes really hard to draw these pictures. Now, why do people like these pictures? Database fanboys. Why do you like these pictures? They're great? They're pretty. Oh, so it's like, you at the comic strip. So just like the Daily Dilbert. So you kind of, you kind of generate your picture of your query and then you look how funny it looks. So what I see is that what people do, since they write their query in a declarative way, now this thing doesn't perform very well. Because maybe, they reversed the order of the customer ID check and the orders ID check, and now the query optimizer got a little bit confused and, its heuristics didn't pick the right query plan. So what people do is they look at that picture and then they say, this is really what I want to happen, and then they go to tweak their query. But that is like me operating the door there with a rope, trying to kind of open the door, and I say, oh, it's closed. Now, how do I kind of move my rope to open the door? It's completely backwards. Okay? So I think what you should do is you should give programmers full control over the operational behavior of your queries. There should be no magic. Optimizers should not exist. That's magic. Magic ponies we use for beer and gumballs, not for query optimizer. Okay? And the database boys have seen this. Everything works well, and then you put it in production, and now there's something that has a space somewhere at the end of a string, and that it's always these kind of little things where just a little change in your query will disrupt the query optimizer. But, Eric, we have ACID. We have transactions. That's easy. Well, I would argue you need transactions in a database because you've taken something that's conceptually one thing, like a customer with its orders and its line items, that's one thing, and you spread it out over multiple tables, and now if I want to make a change, I have to say, oh, stop the world. Let's pretend that this thing was still one thing, and now I can update it. And then we can continue. Okay? So I would say transactions are not a good thing. They are a compensation for the fact that I've taken something that's one thing and spread it out over multiple tables, and now I have to coordinate mutations over multiple things. And as Nathan maybe argued, why would you mutate this thing at all? Databases are extremely imperative. It's all about CRUD. Create, update, delete. But databases, they should not ever throw away data. That's what some people say. But I would say transactions are a good example of that is now, because I've kind of picked a particular implementation, I have to suddenly coordinate mutations across multiple pieces of data. All right. You still love databases? Oh, okay, good. Good. I've already started to rattle their brains. So they are now questioning the database. That's what I want. If even the fanboys in the back of the room are now questioning the database, I mean, I can stop now. Maybe we can have some coffee and just enjoy the rest of the day. But look, this is also job security for you guys, right? Because, the transactions, yeah, that's great. That's like a nice abstract concept. But in order to make your query go fast, you cannot use real transactions. So you have to kind of use, I don't know. How do you call these things? If you have something like snapshot something, is that still a transaction, or is that like half a transaction? And now, you see people, it's like, here's a 3-line query. What is the result if I run it under snapshot isolation? And then you can spend your whole day kind of saying it. And then somebody says, well, no, because okay, so we have to do read committed. And then you can spend 3 weeks to analyze your query, what happens when it's read committed. So all these isolation levels turn queries into exam questions. Okay? And I don't like programming languages where programs are exam questions. Okay? It's like the Java Puzzlers. You know that book? Yeah, it's like, you look at that, it's like, oh my goodness, I didn't know that a 3-line program could do something completely unexpected. Well, here, just pick one of them and you have something completely unexpected. Or maybe my brain is too small to understand this. My brain is the size of a peanut, and I don't know, 5 things don't fit in there. It's just too much. Now, I already hinted at this, but SQL needs a closed world. What does that mean? The query engine needs to control the world. For example, in order to implement transactions, it needs to be able to control all the players. It needs to kind of, and the implementation might be more efficient, but basically what it does, it tells the world, stop. Now this guy can make the changes, and now you can go on. Okay? And we all know how well distributed transactions work. Well, because then you have an open world. So you have to have a closed world. The reason that the query optimizer works, and it can do fantastic things. Of course, I'm using a little bit of a hyperbole here, but the query optimizer can do fantastic things. But they all depend on a closed world. It depends on the fact that the query optimizer knows, your schema, it knows statistics about your data. So it has deep, intimate knowledge of your data. And then it can do amazing things. But these are closed world assumptions. And in many cases, that's not a good assumption. If I have half of my data, say, on Amazon, because, I'm selling, books, and, Amazon is not going to kind of, allow me to use their statistics to optimize my query. They don't even allow me to take part of my query and run it there. So in the real world, in the world of the cloud, in the world of the web, you don't have a closed world. So inside a closed world, this works great. But what do we do when we move to an open world, where, things are heterogeneous, where I cannot assume that there's one single system that has control over everything? Well, that's what we're going to look at next. But let's first look at this table here. So people talk about, when we talk about the open world versus closed world, there is, you've all seen that, the fallacies of distributed computing. Okay? And if you look at all these fallacies, they all have to do with the assumption that you think it's a closed world, or you want things to be a closed world. You want to say latency is 0. Because in a closed world, you control the latency. But on the internet, unless you have a lot of money or you're Google and you can kind of put fiber around the world, then you control it. But normal people like us, we don't control latency or bandwidth or security. Okay? So all the things that people wish that were true about a distributed system are all things where you want to make it look like a closed world. So what I tried to make a similar list about declarative programming. And there also you see that what people wish they had a closed world. That makes it so easy. Oh, everybody just shut up. Leave me alone. Let me be in my little bubble. And then everything is beautiful. There are no exceptions. Look at this. Let's look at this query. Okay. I don't see any try-catch. But, I mean, exceptions happen, right? Things might happen. And in this case, in this simple thing, probably there's no exceptions. But in a SQL query, there's nothing you can do about exceptions. You assume that everything always goes okay. Well, I don't know, but my programs always, first check if the argument is null, throw an exception. Okay, so you cannot assume that there's no exceptions. You have to deal with exceptions. Another assumption is that, as I said, the query optimizer assumes it has statistics about your tables. Well, what if I don't have these statistics? The table is accessible via a REST interface. I cannot ask, how big the table is. Or if you go to Jafar's talk, you don't even know how big the table is. The only thing that you can do is you can ask a query and it asynchronously will stream the results to you. It's not even synchronous because, there's latency involved. Side effects. People have been tweeting, Eric, what is he saying? He loves side effects. Yes, I do. I love side effects. Okay? I'm an imperative programmer. Whatever, maybe we should have the imperative programmers anonymous. I am an imperative programmer and I'm proud of it. Okay? Because every real program that I write uses side effects. And every SQL program uses side effects when it does CRUD. Okay? But inside a query, you assume that there's no side effects. Well, you can write great exam questions where you write a query that inside a query does, deletes and inserts and updates. Beautiful exam questions. And then you throw in some of the isolation levels and you don't know what's going on anymore. Okay? So even though side effects are nasty, they are part of our life. So we cannot just push them away. You have to be able to reason about side effects. Another thing is, well, everybody here that uses SQL, maybe except for the fanboys in the back, that love to kind of, arcane syntax, but most of us, I think, use some ORM mapper, right, where we can write objects and that will generate the SQL. But even then, we have to deal with many, many languages. There's no system that's written in a single language. Now, how can you optimize across different languages? You cannot. So the world is not closed. It's open in all aspects that you can think of. And that's what we have to embrace. Okay? So don't hide. Embrace the open world. Don't try to run from it. It will come back to you to haunt you when you say, oh, let's kind of, no, exceptions. It's so easy if I don't deal with exceptions. Not going to work. If you say, I don't want to deal with side effects, well, only people that use Haskell or Agda in their day-to-day work to write production code have a right to say, yes, this is great. But I don't think they exist. And maybe there's one or two, like the 1% rule, but, most of us, we have to deal with reality. And there's this cute pony inside the database, and look at it. I love her. She is so cute. But I would rather write some code, right? Instead of relying on ponies. Because the real world is open. And that's what we need to do. So, that's the open world assumption. And again, this is this kind of, the duality that I was hinting at. And so I think you have to embrace this. If you just say, okay, I have to assume that everything is not under my control and I have to kind of, take this inconsistent mess and try to make something out of it that works, that's the way to go. Okay? So instead of saying, oh, I wish that I have something beautiful, I wish there's a pony, you should assume that the pony has been there and it has left you know, certain piles of smelly things that attract flies, and you have to clean that up. That's the real world. Okay? That's the real. And you all know these people in your company probably. They come in with a pony. Management loves ponies. Okay? The people get promoted, and they are on to their next pony project, and now you are left behind to clean up the mess. Well, that's what I do. I'm a janitor. That's my work. Okay, programming. This is a conference by developers for developers, and we're going to write some freaking code. Okay? So this is, by the way, is a great website. I think Dave is one of the people that kind of, you know, is behind the Agile Manifesto. He has the programming MF manifesto. So go to this website. Fantastic. Okay. And no offense intended here. So, okay. But, before we're going to do some programming, I cannot do a talk without talking about monads, right? I mean, how can Eric Meyer do a talk not talking about monads? Now, I noticed that there's now already a lot of people that talk about monads. So, monads are now common sense. Everybody knows monads. I don't have to talk about them anymore. So instead, I'm going to talk about comonads. Okay? We're talking about comonads. Let's see. So, well, in Melbourne, people were saying, Eric should talk about comonads in JavaScript. It's like, oh, JavaScript. Yeah, I like JavaScript. It's a fun little language. Comonads in JavaScript. So, I was looking for a JavaScript library that has comonads. And .NET, anybody here has used C# await? Few people, not enough people. So you can forget everything that you heard in this talk, okay? Forget everything. After this talk, you go back to wherever you are, you take out your laptop. Maybe you can take out your laptops right now. You install C# 5 and you play with async await. Async await is syntactic sugar for comonads in C#. Okay? So C# 5 has syntactic sugar for comonads. You didn't know that. Well, the C# designers didn't know that either, but it's true. It's true. Okay. So what is a comonad? Well, I'm going to explain to you. But the comonads are, you know, task of T is a comonad. So if you look at that signature there in the middle, you see this continue with. Let me see if my mouse works. So this takes a continuation function. And this thing is a method in task of T. So, and it takes a function that as an argument takes a task of T and it returns a result. And then the result is a task of T. So the fact that the continuation itself takes a task of T, that makes it a comonad. Alright? So now I don't know, I haven't seen Michael in the audience yet. But Michael, the rumor goes that he has written the first JavaScript library that uses comonads for futures. Is Michael in the audience, or is he? Have you finished it? What? It's impossible. So I mean, the poor Michael, he has been hacking all night, and now he tells me it's impossible. Well, in C# we can do it. So I don't think it's really impossible. Maybe in JavaScript it's impossible. But, so the challenge is still open. Maybe we should have a Kickstarter project to kind of, you know, to write a comonadic, library in JavaScript. But it's really easy. So, it's really easy. Comonads are really easy. Comonads are gumball machines. Okay, so, you know, if you're programming in C# async, think of programming gumball machines. That's all comonads are. So let's look at what comonads allow you to do. Okay? So what can you do with a gumball machine? The whole point of a gumball machine is that you can get a gumball out of it. Okay? So it's like a promise of a gumball. So that little kind of dial that you have there, that's like a promise. You can have your kid there and say, if you're really nice and you shut up the whole day at the end of the day, I promise that you will get a gumball. Okay? So a gumball machine is like a promise or a future that maybe at some point, when it terminates, if you turn long enough, it will give you a gumball. Okay? So it's a promise or a future that sometimes will return you a value. So you can remove it out of there. Now, unlike Hotel California, where you can only check in but never get out, that's a monad. In a monad, once you're in the monad, you cannot get out. With the gumballs, it's the other way around. Once you have taken a gumball out of that machine, please don't put it back. Okay? Imagine that this lovely lady has taken the gumball and licked it with her beautiful tongue and now puts the gumball back. You don't want that to happen, do you? So gumball is, once it's out, you can never get it back in. Okay? And just think of this and you will never forget this. Okay, and Eno promised ponies, so we also have ponies in the comonads. So imagine that I have a magic pony that besides doing query optimization, can also turn gumballs into beer, so it can also do something useful. Now what I can do is I can put that little pony not in the database, but inside the gumball machine, and now she turns a gumball machine into a beer machine. Wow. Okay. So that's the map function or the select function. Okay. So in that sense, a comonad is just like a monad. It's a collection, and I can apply a transformation on the elements and I get a new comonad or a new gumball machine that instead of gumballs has beer. Okay. Makes all sense. I mean, you can imagine, there's a secret door in the back. The pony, and I put a little bit of grass in there, and the pony is happy and turns gumball machines into beer machines. So that pony is always works. If you have trouble, bring in the ponies. Now here's another thing that you can do with the gumball machine. I can franchise a gumball machine. This is what we developers love to do, right? If I have a gumball machine, imagine that I can turn that into a machine of gumball machines. And now, if you turn, I get out a gumball machine. Well, this is franchise, and this is what a comonad allows you to do. If I have a promise of T, I can turn that into a promise of T. So I can kind of franchise this thing. I can duplicate. I can, duplicate that thing. Good. Now, once we have that, we can combine these two. So imagine that, I have something that turns a gumball machine into a machine with gumballs. Now I have a function that turns gumball machines into beer. Okay? And then, what I get if I compose those, I get a machine that turns gumball machines into beer machines. So that's what I want, right? That's what I was after, to turn gumball machines into beer machines. Well, I can do that by this composition of functions. Well, the second function here, or this composition of this function, was exactly that continue with that I showed you in the task of T. So continue with takes a magical function that turns gumball machines into beer, and I can now use that to turn a machine with gumballs into a machine with beer. Well, maybe the JavaScript hackers had too much beer, or maybe too many gumballs, because that has all this kind of artificial coloring, and that also has some effects, on the brain. I think if you give that to your kids, they go hyperactive. So we'll see. So I'm still, the challenge is still open. I will buy you 4 beers if you can define this library in JavaScript. I'm upping the ante here. 4 beers. Or you can have a whole gumball machine. Okay. So that's all a comonad is. It's something that you can take something out, and if you have a gumball machine and a function from gumball machines to a result, then you get a gumball machine or a machine with the result. That's all it is. And as I said, C# has support for this in the language with async await, but it's not that hard. Okay, comonads are not that hard. It's simple. Now, everybody, you can explain comonads to your coworkers. Workers, co-workers. So those are the people that never do anything and you work. They are co-work. It's a good name, co-workers. I love it. I never thought of it. All right. End of the intermezzo. Let's go back to the regular program. You can check the time. Good. All right. I promised that I would show you some code. Okay. So what is important for developers? Okay. Developers work in terms of verbs. If you define an object, it's all about the methods on the object, right? That's what you learn. You go to, your first programming course, and it says you define your object, but all your fields, that's private, and you expose, the functionality of your objects via methods. And methods are verbs. They do things. They mutate the state of the object. Object orientation is the revenge of mutable state. Okay? You have your state and your objects, and the only role in life for methods is to change that state of the object. And to do it in such a way that you don't expose that state. Okay? So I think objects are fantastic. And if you go to Wikipedia, which is the source of all truth, it will tell you, right? Objects offer simple to use. That kind of depends, depends, a lot of objects are not simple to use, but hey, it's Wikipedia. And standardized, so we all have to go to ECMA standardization or ISO, whatever, 4561, to, have our objects, standardized. But the most important thing there is it conceals how these methods are implemented. And that is super important. Remember, the database where all the foreign keys and the primary keys and everything was exposed? In an object, you hide that. And why is that? Look at that second sentence. Is now you can change the implementation of the object without having to change all your consumers. And the way to do that, and Wikipedia doesn't say that, what you're doing there is you have to separate the interface from the implementation. So if you're a good programmer, you always should you should always program in terms of interfaces. Even concrete classes is bad. Always use interfaces, because then you can vary the implementation of the interface, and then you can use something fancy like dependency injection to create your interfaces, or I don't know. So that's kind of weird, right? Interfaces are super important, but then no language has a good way to create instances of interfaces. And then we have to go to weird things like dependency injection, and put XML files with our code, and I don't know. So that's something that needs to be solved, but so that's also full employment theorem for language designers. But the important message here is separate interface from implementation. So let's look at an example. And this is interfaces gone berserk. Okay, you go to the .NET framework, and you look at the dictionary class. Okay, so the dictionary class was designed in the olden days when there was only single core, so they're not thread safe and so on, but that's good. But look at this. It implements a whole bunch of interfaces, but the most important ones are the top 3 ones. Okay, what is a dictionary? Well, that's something that implements iDictionary. Okay, so really whether this thing is called dictionary or foobar shouldn't really matter. The thing that matters is that it implements the iDictionary class. It also implements iCollection of key value pairs. What does that mean? Well, I can forget about the fact that I can look up by key, but I just can get a collection of key value pairs, and then I can just index in that collection by position. Okay? Or I can say, just give me a sequence of key value pairs, and I don't even care about indexing. I just want to enumerate all the key value pairs. Okay? So that's how you should define a collection. You should not define a collection. And look at this. It doesn't matter where there's customers or orders or anything in this collection. Whereas in SQL, whenever each table defines a collection, but I have to define the table again and again and again. There is no abstraction for table of T, or something that says it's a table of T with something. No. You have to, there's no reuse in SQL. That's why it's also full employment, right? You have to start from scratch all the time. You can start new project every time. Okay, but here, somebody, hopefully smarter than us, has defined the implementation of the dictionary, and we just program against the interface. And now there's all kind of, how many other interfaces here. But let's look only at those. Now, what is the advantage of this? Well, this was defined, as I said, in the time of single-core machines. But now, we all have, I don't know, at least 4 cores on every machine. Even your phone has 4 cores. So now, we have to make thread-safe collections. Well, we can do that. Let's go here. And then I'll go back to those ones. If you look at .NET 4, they introduced Concurrent Dictionary. Now, Concurrent Dictionary, look, it implements the exact same interfaces. Okay, so this is an example of what Wikipedia said. If I programmed against the interfaces, if I never programmed against a concrete dictionary type, I can just slot in a new implementation of my dictionaries and my code wouldn't change. Okay, now in practice, it's never as easy as that, because now I'm falling into the fallacy of the closed world again. But at least, the changes are, not disruptive, because the interface is still kind of the same. And what can you do? Well, you can add something to the dictionary, you can clear it, you can remove it, you can try to get the value, and that's the kind of operations that you want. And now you can have multiple implementations of this interface. Now, why is this good? Well, if you want to build a program that uses collections, you can take one of those collection classes, and everybody here probably has written, what is it called? Data, forms over data. I mean, somebody told me that this is like 90% of what people do. You write a UI that manipulates data. Well, how do you do that? You do that by binding your data, your list to a UI, and when you mutate the list via the UI, you add and remove elements in the list. Right? And everybody can do that. This is how we write UIs. You do data binding of your UI over your data structure. Now, if I built a UI over dictionaries, I can use the same UI, I can use the same principle to define a UI over a concurrent dictionary. Now imagine that we would have a new dictionary that doesn't live on your computer, but that lives in the cloud, and that is, replicated and highly available and whatever, and still has the same interface. Okay, so now what you can do is, you don't need a database, you just have the list, because that's what I want, right? I want to have a list of customers, but now imagine that list would, always be there. So if I turn my computer off, it's okay, because that list lives somewhere in the cloud, and the implementation of the list makes sure that list, once I have the handle to it, which now will not be a pointer in memory, but some URI somewhere to a service, that list will be there, as long as I pay. Okay, as long as I pay my Azure subscription, that list will be there. And otherwise it will be garbage collected. It's like a weak reference, but you have to pay for it to keep it alive. Well, that dictionary could implement exactly the same interface. Wouldn't that be fantastic? So I can just swap out the implementation for this implementation that lives in the cloud, and I have a data structure that I can program against. Okay, and that's my dream. This is the dream that I'm chasing. I want to take regular data structures and change the implementation and minimize the changes to the interface and make them live in the cloud. Instead of the heap of your computer, I'm using the cloud, Azure, EC2, your own data center, whatever, as the heap. Okay? And now I just hope, I hope that somebody else that's smart enough that can build, like, the Basho guys or whoever that can build, these distributed systems, that I can run my lists on them. So what could you do? Imagine that you would have this, okay? Now you want to write a game. Well, what you do is you just create a sorted list in the cloud. You connect to it because, it lives somewhere. So if I have the URI to it, I can connect to it. And now I can just add something to it and, I can take the first 10 elements and this all works. And I said I may have to change the interface a little bit because now, since I'm in the cloud and it's not an open world, all these things are now asynchronous. So I have to use my comonads to access my data structures in the cloud. So these comonads are not just like a joke with gumballs. These comonads are essential to write asynchronous code that lives in the cloud. And if this thing gives me, in this case, this take async, might also, this is what Jafar will show you, instead of returning asynchronously a collection of 10 elements, it could also asynchronously stream to you 10 elements. So that's what you will see in Jafar's talk. Okay, so that would be actually a little bit better than this. Okay, but this is the programming model that I want. You program against the interface and then the implementation can be remote. Now this is not science fiction. Okay, this is not science fiction. Who here of you uses Redish? A couple of people use Redish. Probably you were you thinking, oh Eric, that's just Redish? Yes, look at that. Fanboys over there, have you used Redish? No? Go, open your laptops, go look for Redish. It's super cool. Because Redish exposes data structures as a service. So Redish has things like sorted lists and sets and whatever, and they live in the cloud, and you can just kind of do the operation. Is that correct? Is that how you use Redish? Do you love Redish? Exactly. Okay. Then there's another project that's called Kept Collections that takes the Java collection classes and implements them in the cloud using Zookeeper. Okay? And then there's a whole theory, I think Justin also kind of mentioned that in his talk about commutative replicated data types, that if you know kind of certain properties of your data types, then even though you have an open world, you can still reason about the operations, because if they commute, well, it doesn't matter if you have an open world, because, that's what commuting means. You don't assume that things come in a certain order, so it works well in an open world. Now, I want to make a small intermezzo here, because people will say, but Eric, if you're doing distributed systems or web-based stuff, shouldn't you use REST? Well, no. Okay. I think REST is one of these other big lies in our industry. Okay. If you have a REST API, if somebody gives you a REST API, what is the first thing you're going to do? Just like when somebody gives you a database, what is the first thing you're going to do? You're going to write an object wrapper over your database. And if I give you a REST service, I bet you the first thing every developer does is to write an object wrapper over it such that you can talk to this REST service as if it were objects. And then people say, oh, distributed object is bad. No. We want objects. We want verbs. We want to kind of, mutate the state by calling methods. That's what everybody does. And the Google guys here have a great quote. So this is some distributed event processing system. And look at this. What they say is that they first had a REST API, and their users said, no way. We don't want this REST stuff. We want APIs. So they first try to please their users by giving them APIs. And this is what you see also, right? Every REST API, you go to Twilio or whatever, they all have client libraries that hide all the REST stuff and expose it as objects. But look at this second thing here. It's like more or less like, as a side comment. But look at this. That API allowed them to change the underlying implementation. So if I want to swap out REST for pigeons that fly, because, the internet can go down, but pigeons will never. I hear that the Israelis have a whole system, a whole internet based on pigeons. Okay? So I could swap out the implementation to use pigeons, and you can still use the same API. It will be a little bit slower, but since you use comonads, it's okay, right? So comonads and pigeons to build your APIs. End of intermezzo. Okay, so how I'm going to build this? Imagine that we want to build these objects that live in the cloud. Now, one of the things that I want to do is I like to build a system that is open. Okay, so what I don't want is that it's really hard to deploy and use these things. Okay, now if you know ASP.NET, and I think other web servers have the same thing, if you want to deploy a new server program in ASP.NET, you just drop your code in a directory, and then when the next request is handled, it will pick up the code from there. So deployment should be super, super easy. Now, I know a language where deployment is really easy. It's called JavaScript. And deployment is called monkey patching. So you all thought monkey patching was bad? Monkey patching is fantastic. This is, mutable state in its best. Okay, because what you can do is I can take an object and I can just ram a new method in there and I've deployed my code. Wow! Look at this. So let me show you the example here. Okay, so there's my little JavaScript object and it has two fields. And this is also what I mean by not being first order. In JavaScript, a JSON object is just a hash table. It has keys, the things on the left side of the colon. And then on the right side can be anything, any value. Okay, it can be a string, can be a function, or can be another object. It doesn't matter. Okay, this is compositionality. It's not just, something that has strings or integers, like a table. No, it can be anything. That's what we want. It should be anything. The language should impose no restrictions on the composability. Now, I will not explain what this means in JavaScript, because then, I will need a whole day and your brains will be all over the ceiling here. But, there will always be a coworker that knows exactly how this works in JavaScript. Another great exam question generator. Here's a little JavaScript program. What does it do? Oh, is this bound like this or this bound like that? But anyway, let's just assume that, in this case, this does the right thing. So if I run this little program, so I call the speak method here, it will say hello. Now, how does it know to say hello? Well, that's because this, this, gets magically bound to the text. Okay? So in this case, this works. So if I do this.text, I get the text hello. So now I want to, in place, change the behavior of this thing. Easy. I just change the text. Now when I call this method again, it will say hello Yao. Isn't that great? That's what the object orientation is finest. But now I can, deploy some new code to this program here, or to this actor. I just say, actor.speak is a new function, and look at this. Where's this bound? I don't know. But when I call it, using that syntax, with square bracket, it does the right thing. Okay? So, what we want is imagine now that we can take this model, have these JavaScript objects, or something that implements this model, where each of these, actors lives in the cloud, and I can send it code to update, its behavior, or I can call methods on it. Okay? So now deployment just becomes monkey patching of my JavaScript objects. And this thing will run always, because if I intercept all the mutations via the magic this, then I know exactly when the object is mutated, so I can look at these changes and then, decide to replicate them using, React or something. And now, this thing will be there forever. As long as React, as Justin has done his job, your object will be safe. Okay? So this is what we're going to build. And as I said, we have to separate interface from implementation. So what we're going to build is we're going to build something that has state that we can mutate. Now, put on your seatbelts. Because we're going to show some really weird interfaces here. So let's start with the easy one. Okay, so this is another great thing of C#. C# says if you want to do dynamic typing, it's fine. You just use a static type to indicate that you want to do dynamic typing. So here I have something with static type dynamic. So I have a set method that takes a key, which is a string, and something of any value, dynamic, and I can update that key with that value. I can get the value, or, it might be that I want to try to get the value, because I don't want to, like in JavaScript, we talked about the weirdness of this, but there's also null and undefined and triple equals and for triple equal. I don't want to go there, right? So we just do try get. And then I also might want to delete keys. So in JavaScript, you can delete keys from your objects with delete. So we have that. So these first 3 or 4 methods there just give me the same thing what a JavaScript object gives me. And then I have my last thing. This is the new thing that allows me to replicate this thing. So that's like, to commit the transaction. Okay, so I can start mutating my object and then I say commit or replicate, and now it will replicate. So I'm stealing the good ideas from the database world. Okay, so these objects are a little bit like little transactional things where I can mutate them and then I can say replicate, but I'm using whatever backend you have, React, Redish, I don't care, but this is kind of what's going on in the background. Now this is an interesting one. So now I told you, I have to be able to mutate this. And I have to be able to call things on this. So how do we do that? Well, we do that by having an eval function. People think that eval is evil, but I think eval is great. Okay? So what this thing allows you to do is to send a function to this little actor. Okay? The actor will pass you its state, which is this interface. And remember, I want to implement that interface in a different way for whatever different backend storage I use. Then I get a list of parameters, and it returns me a result. And then I'm using the old C trick that I'm passing the parameters separately, such that this thing, that function, doesn't have to be a closure. Because it's easier to kind of, send a function pointer around and not a closure. So that's just like a little trick. Okay? But once I have this, I can mutate my object, and since everything goes via the this parameter, I can use the magic of replication. So here is some code that, if I want to implement this little thing, where I get the text, well, what do I need to do? I need to run that function, set the actor on slot speak. I have to put this function. So what this thing does is it sends the function here where, one of the things in my argument list is the slot and the function that I'm doing. So this is how I patch up, how I said actor.speak equals function. Okay, and of course you're not going to write that code up there, but the compiler will generate that, or the system will generate that, but that's what's happening down there. Okay, so I'm updating the speak function here with something that gets the text and returns it, and here I set the speak function to that. And this is how I run it, or if I can use my this is another way to do that, where you use custom attributes, and now we generate all that for you. Now, as I said, I only have a few minutes left, and the demo gods were not happy with me, so I'm going to show you screenshots, okay? But you can come to me afterwards, and hopefully the machine is up. So I'm going to a few screenshots here, of how this works. So here's an example where I have a method, and you see there there's the custom attribute actor method there, and it says hello world. And now I redefine this thing, I recompile, and now it says hello Yao. Okay? So now this is a little UI on top of this actor. So the first thing I call it, and it says hello world. Then I select number 1 on the menu, and then it uploads that new code, just like in this JavaScript thing. It monkey patches the actor as it's running, and it now says hello Yao. Okay? So you see how easy it is to kind of on the fly monkey patch your object by just redeploying code to it, and it keeps running. And this is, how you see I can shut down any of these replicas here, and then, the system is highly available, brings another one up, and my object still works. And then the other example shows you how to kind of data bind a list. So I have now two UIs that bind to the same list that works in the cloud, just like people do with Redish, and I can really easily make like a chat thing or something like Trello, where you can kind of, do one movement here, and then the changes get reflected in the other one. Okay. So, now I talked about comonads. What about monads? Eric, you don't love monads anymore? Well, Gilad has a interesting blog post where he says, well, monads are not good, you have to use actors. Well, I showed you here an actor system, but I don't think Gilad is right in this case. Gilad is often right, but not here. Because when you're building a distributed system, because you have to deal with, things that might go down and so on, you want your operations to be idempotent. Which means that if you call the same method twice, you want this thing to be the same as calling it once. Guess what? You can use monads to do that. Because we control all the state changes, we can automatically make these things idempotent. So, and independently of us, some people at Microsoft Research had already discovered this as well. So we implemented the idempotency, but they did it as well, and they have a paper about it. So if you want to know how to use monads to make your operations, this is the state monad that makes it idempotent. And again, for the SQL fanboys, we're really using all the tricks from transactions in there. So we love databases. We absolutely love databases. And if maybe, you have listened to this talk and you said, I remember this paper by Pat Helland from, 10 years ago or 5 years ago, where he was basically saying the same. And that's exactly true. He calls it data on the outside versus the inside. I call it open versus closed world. So in a closed world, the database is fantastic. The SQL fanboys are absolutely right, okay? I was joking with them, but if you're in a closed world, nothing beats SQL. Because SQL really leverages and it kind of, squeezes everything out of the closed world assumption. It's fantastic. So if you're on the inside, if you're in a closed world, you use SQL. But if you're in an open world, then your assumptions are different, and then you have to do something different. So it's really, you have to be mindful of where you are. Are you in the inside or are you on the outside? And I can recommend everybody reading Pat Helland's paper. And then this is a last commercial. If you really think that I have lost faith in functional programming, you should look at my lectures on Channel 9 about functional programming, and you will see that I'm still a believer. I'm not a sinner yet. So thank you very much. Do we take questions? Questions? No questions?
So my question is about, you've got these interfaces with mutations on them, and you said, as long as all the mutations are commutative, then that's all good, but you can't mutate a single object and add the same field to it. That doesn't generally commute. So don't you need some like conditional update, or you need to change your interface to make that sort of work?
Okay, so this is a very good question. So remember that this is a very general interface. Okay, so what I want is I want something, an interface under the covers that is non-prescriptive. Okay, so I want you to do everything you want. Now, on top of this, I can build something that assumes that things are commutative or, associative. But the underlying infrastructure should not enforce anything on you, because I also want you to be able to do things that are not commutative. But in order to make things efficient, it's better be commutative. But I don't want to restrict the underlying model to only allow associative or commutative operations.
How do you deal with the fact that two people read an object and they both try and write something different to the same slot?
So that is the implementation of this of the state. You give an implementation of the state that handles that.
So what, throws an exception for one of them? Or?
Yeah, maybe. So again, and maybe this interface is not the correct one, but what I've tried to do is to say, look, I give you this is the most general interface I can imagine to do updates on a key values store. Okay? And now, you can plug in your implementation that has the behavior you want. Maybe this interface is not good enough, and then I'm happy to kind of, you tell me what I need to remove or add, but that's the idea. But I don't want to force people to always, do this, because maybe you want to have something that's not replicated. If you want to have a stateless server that just goes away when the machine goes down, this replicate will be the identity, and then it can just, add and remove or update, concurrently.
You need the transactor.
Yes, he needs a transactor, yeah.
Transactors help, but you also need like a function for the update. So you say, set, give me the old state to the new state.
Yes.
Longer
conversation. We can talk about that, because that's kind of more or less hidden in here. So this thing assumes this thing happens like one at a time. So.
Eric will be over at the red table over there, so we'll take the rest of the questions over there. So we can.
Okay, thank you very much.